Here is my poor RME UFX, and it is not working. This just happened to me the other day. I would get 4 solid bars in this window over here, and I wasn't getting any audio. I did figure out that some of the digital outputs and inputs would work, but the analog channels were not working. Today I'm going to repair it, and I'm going to show you what was wrong with it and the most common issue with RME products as far as them failing like this and how you can fix them. Let's get on with it. Let's talk about how you get the RME UFX apart. And this is probably going to be similar for a lot of their devices. There are some screws you'll need to remove. On the back panel, there are 1, 2, 3 screws that you need to remove. On the side panel, there are 1, 2 screws to remove on this side, and 2 screws to remove on this side. This one is covered with a metallic sticker, and it's just a tamper sticker so that they know whether you've been in the unit or not, and it would void your warranty, but these are long out of warranty. Also, you're going to have to take off the rack mount ears. These just are held on by 2 screws. These 2 little screws right here, and you'll just unscrew them from the bracket on each side. Once you've done that, you should be able to gently lift off the lid. You want to lift it from the front because it is still connected. There's a grounding wire to the case. It's just a spade connector, so you'll just pull it off. Let's see if we can get that into focus. It's just a metal connector. Just slides right off. Once you've got this lid off, you're inside the machine. Here's an overview of the power supply. We have a large capacitor over here. We have two more right here, another two here, and then 1, 2 here. And this is our bad capacitor, and I've marked it with some blue magic marker. I'm going to give you a close-up view at a different angle so that you can see that it's bulging and that it's damaged. And this does appear to be the capacitor that fails in most people's RME UFX devices. You can also see there's two large heat sinks here, so that's putting a lot of heat over here. There's another large heat sink over here. Let's take a look at that other angle. Here's that other angle. Here's some of the capacitors that we're dealing with. Got some power regulators here on these heat sinks that I was talking about. And here is our bad capacitor. This is the one, like I said, that seems to fail a lot on people's devices. I put some blue magic marker on it so that you could see that it's convex here and that it's bulging and the electrolyte is trying to get out of it. There are some smaller electrolytic capacitors that I didn't identify. Usually they're pretty reliable and generally I don't mess with them. Today I'm going to go ahead and remove this capacitor and replace it. Now, like I may have said already in this episode, conventional wisdom says that you should replace every capacitor on a power supply when you're recapping it, not just one. But I'm only going to replace one, and I have my reasons, and I'll talk about that in the wrap-up. Let's get this capacitor replaced and see if the device is going to work. So just like that, new capacitor is in. Here we are at the moment of truth. I can't tell you how badly I want this to work. I'm going to turn it on and it's going to either explode or not work or not do anything, but let's see. Looks promising. Yes, I think that's a fix. Before I would get 4 bars over here in channels 1, 2, 3, and 4, or at the end, and they would just be stagnant there. Also, the lights would appear constantly, but that could be because it's not plugged into anything. So I'm going to put it back in my rack, and then I might do a quick video with it actually working, if it will work. It looks like it should. Anyway, I think we've gotten success here. Thanks for your help. Okay, let's talk about the components you'll need. Up in the top left corner, we have a big blue capacitor. That's a 68 microfarad 400 volt capacitor. Also read the notes I wrote about buying these components on Amazon. Up in the top right corner, we have two 2200 microfarad capacitors at 16 volts, and one of those was our bad guy. Below that, we have four 470 microfarad 16 volt capacitors. And last but not least, for our capacitors, we have two 100 microfarad capacitors at 63 volts. I also want to point out that this power supply has a fuse that can be easily replaced by the user. If your RME is completely dead, meaning the display does not light up or none of the other functions light up, it may be the fuse. When you first open the interface, visually inspect the fuse. It has metal end caps and a center portion made from glass. This allows you to see inside the fuse. You should see a thin metal wire running from one end to the other. If it is broken or missing, the fuse is blown. Replacing a fuse is easy. Make sure the power cable is disconnected from the device and the power switch is off. Carefully pull out the fuse with your fingers. Generally, fuses have the specs engraved on the end caps. Fuses are very cheap on Amazon or at your local automotive store. Typically, they cost about 60 cents each, but you'll probably have to buy a bunch of them, maybe 10 or more. Replace the fuse, plug in the device, and turn it on. If the fuse immediately blows, there's probably a short or other issue with the power supply. But there are lots of reasons why a fuse can blow, and you may get lucky and the device may work. A fuse can blow if there is a power surge to the device, or if the fuse had a manufacturing defect, or it's just simply old. In very rare circumstances, a fuse can blow, but the wire becomes broken inside one of the end caps, and a visual inspection will not reveal this. You can use a multimeter continuity test to verify if the fuse is good. If you don't have a multimeter, you can simply replace the fuse and see if the device now works. Okay, it's time to do the wrap-up, and the first question I want to answer is, why didn't I completely recap the power supply? That would have been 13 capacitors. I think it's 13. The 9 that I showed you, and then 4 more little teeny tiny electrolytic capacitors. And my reasons are about 3 or 4, and they're all connected. And the first one is all the capacitors look good that were still in there. And this is linked to number 2. And number 2 is the device is only 13 years old. You shouldn't have to recap a power supply after only 13 years. My Juno 106 is 41 years old. I'm the original owner, and I haven't recapped that power supply since I've owned it. That's truly amazing. I think what happened in this particular instance is there's a large heat sink next to that capacitor that died, and I think that's probably the hottest rail. It's probably a 12 volt or an 18 volt rail, probably 12 volts, but I don't know for sure. If I'd been smart, I would have looked at the power regulator and got the number, and I could have told you that for sure. But I think that cooked that capacitor, and you could call it a design defect, or you could just say that, hey, 13 years isn't bad. And I have no complaints about my RME device. I love it. It's been bulletproof to this point, and it was easy to repair. So that's another reason why I didn't recap the whole power supply. I'm pretty sure that this capacitor, the one that I replaced, will fail again within about 13 years before any of the other capacitors fail. I visually inspected them. There's no coffee stains on the top of them. If you're familiar with capacitors, they can either have a K design, a T design, or an X design on the top, which are little cuts into I think it's aluminum, that allows them to split apart when the electrolyte needs to come out of them. If they didn't do that, then they would just explode and you'd get electrolyte substance all over the inside of your machine, and nobody wants that. So that's another reason why I didn't replace them. I feel that this capacitor is going to fail again before any of the others do. I think just because it's close to that heat sink. Reason number 3 is there's no bench fee for me. I'm fairly good at just replacing small components on a board like this. It's not a big deal for me. I've done a lot of soldering. I was better at it when I was younger because I was doing it more often. And now I do it like once every 6 months, and I have to kind of familiarize myself with good soldering technique and that kind of a thing. but I don't have a bench fee. If you took, or I took this device to my local repair store, they would charge me $100, $150 bench fee. Where you are, it may be cheaper or more expensive. I live in California and it's very expensive here. But I can just yank the device out of my rack, and if another capacitor fails, I'll just fix it. It could be 10 days, it could be 10 months, but I think it's probably going to be about 13 years. And if I'm still on YouTube, when it fails again, or if it fails again, I'll do a video on that. So number 4, and I think this is my last reason here, I've had some bad luck lately fixing some things. And like I said, when I was younger, I was doing it a lot more often. I was doing it for my friends. Their things would fail and I would fix their devices for them. And I haven't done a lot of that lately. And it's just basic electronic skills. I don't have any serious experience doing this, just a little bit of basic skills. And that's gotten me by. I have a D50 that's sitting on the floor over in that corner. And it's there because when I was soldering a new power regulator into it, I lifted one of the traces and now I need to run a wire, and I just was frustrated with it and just put it in the corner because I didn't really need it because I had another one. But I sold that unit, so now I need to get this one working. But, you know, bad luck. If I replace one component on a board, I'm pretty sure I'm going to be able to be successful at it. If I'd pulled all 13, I think, of the capacitors off and then replaced them, there's a chance I switch the anode and the cathode, the positive and the negative, and then it's not working and I've got to troubleshoot it some more. And only replacing one component instantly told me whether that was the problem or not. If you change all of them, you just don't know. And if you still have a problem, you wouldn't know if it's the capacitors you just put in or whether it's something else. Now, for experts that do this all the time and have a solder sucking, soldering iron, I don't have one of those. In fact, my solder sucker died on me when I pulled it out, and I had to use solder wick, which is not a good way to go. I just don't like it. But anyway, that's my reason for not recapping the power supply. And I know conventional wisdom says you should do everything, but I think I'm going to be okay here. And if I'm not, I'll live with the consequences because it was my choice. The other thing I put up in text was I was looking for Nishikon or Panasonic capacitors, and my go-to place usually is DigiKey, and I went to DigiKey. But the problem with the 2200 microfarad capacitors that they had on there, I couldn't find any that were the right diameter. They were all too big by about 1.5 millimeters or 2 millimeters, something like that. And I wasn't sure that they would fit into that tight space. There were a lot of other components around them that were going to be really close. So they would probably be touching. And the other option would be to have the lead stick out a little bit and then lean the component over. That would have put it closer to the heat sink, which would not have been good. And also, that's bad etiquette. The whole reason for electronics of this type is to have them surface mounted because they're a lot more robust that way. So I decided to go with the right size capacitor, at least the physical size. And I got those on Amazon, and I already put up the information on that. And so you can use that if you want to buy there. I don't get anything. I'm not sponsored by anybody. Next up, I talked a little bit about fuse troubleshooting, and I think that's important. If your device is completely dead, a lot of these devices have fuses in them, and that's a good place to start. If you take the device to a repair store and it's just the fuse and they replace the fuse, they're still going to charge you a bench fee of $100 and $1.95 for a fuse. So it's in your best interest to open up the device if you feel comfortable doing that. I don't want to push anybody to do anything. It's entirely up to you. But usually it's 10 or 12 screws, and really taking this device apart and repairing it was not that hard. And I know I have some experience doing it, but I think I can be pretty objective, and it really wasn't bad. It's a really good design. And I've been inside a lot of my rolling gear, and on one side, from your perspective, looking at the front of the device, the electronics are over here and the power supply is over here. And this power supply came out with 4 screws and disconnecting 3 connectors. Now, 2 of those connectors were really on there. They were really tight, and you've got to be careful taking those out, or you could have more problems, and you don't want that. So the last thing I wanted to say was, I don't know if anybody has any interest in me doing a little simple repairs for musicians, like replacing capacitors and soldering. I'm not sure that I'm qualified to do it, but I'd be willing to do it. I had 1 year of electronics when I was still in high school. In my senior year, I took 2 afternoons off and I went to the local community college and learned how to solder and use an oscilloscope and a multimeter. And I don't own an oscilloscope, and I wouldn't know how to use one now if I had one, because that was a long time ago, but I do know how to use a multimeter for continuity testing, for resistors, for simple things. And so if somebody is interested in that, I'd be happy to do it. So just let me know in the comments. I hope you were successful and that your device is working again. If it was that crazy 2200 microfarad capacitor, it really wasn't too hard to remove it and put a new one in. At least I found it pretty simple, and I think for most people it would be too, especially if you already have some soldering skills. So I hope you were successful. Anyway, that's it for now. Take care, and I'll be back in another episode soon. Bye.